So, welcome to the South Dakota Mines Mechanical Engineering Research Seminar. This is April 22nd, and this week we have Eric Reynolds Brubaker from Stanford University. He's a PhD candidate in mechanical engineering. He is a graduate NSF graduate research fellow, and he's in the Center for Design Research and the Designing Education lab. So he'll talk about um, engaging undergraduate students in a design and manufacturing course and their sense of belonging, as well as looking at PhD students pursuing their studies and how those students persist. So, an interesting range of topics, but all under the umbrella of belonging and access. So, it's certainly relevant for our students here at Minds, and I'm looking forward to learning a bunch. So, Eric, I'll hand it off to you. Thank you, and go ahead.
Thanks, Micah. I'm grateful to be here. Can I just do a quick time check? When should I try to be done?
Yeah, so we'll run probably up to the top of the hour. So you could leave, 5 or 10 minutes for questions.
Okay. Okay, cool. And since we're a small group, at least synchronously, if any of you have questions as I go, please feel free to jump in. So as Micah said, I'm a PhD student at Stanford. Before coming back to school, I did my undergrad in Ohio at Ohio State. That's where I grew up, and worked as an engineer in R&D at a place called Battelle, and eventually ended up doing some teaching in a group at MIT called D-Lab, teaching design and manufacturing. And you'll see in a second, my experience at MIT is what first got me interested in belonging and how different people, different students, but also faculty and staff perceive belonging in a education space, and why that matters. It doesn't seem like it's not a technical topic per se, but it ends up really mattering for if we want to make engineering accessible to everyone. And thereby have better products and better systems to address the challenges we currently face. You'll see in the background of this slide that the Earth and a satellite view of lights, at night. So this is Earth Day, as some of you may know, and so this is in celebration of Earth Day and us working on the challenges to help us live sustainably on the planet. My other research has more to do with that. So I'm just going to start with this quote from a report that was done at MIT back when I was there. I'm just going to adjust so I can actually see this moment. Apologies. Okay, so it says, we barely finished the lab one time and headed out. My partner was in the elevator, but he didn't see me. He was too busy talking with a friend of his, explaining how upset he was about barely finishing the lab and debugging the circuit for so long. I guess his friend saw that I was his partner, but not seeing me in the elevator, because he said, well, that's what you get for working with a girl. These kinds of labs aren't really their thing. My partner just laughed and said, yeah, explicative sex. So this was a woman, and in the electrical engineering computer science department at MIT, an undergraduate student. And this is just one example to illustrate the kinds of situations that students who are in a minority and thereby are minoritized in some way in engineering face. And these things happen, every day in some cases. And so that leads sometimes folks to feel like they don't belong in the space. So belonging is defined as the fit or anticipated fit between a person, who they are or who they can be, and what a setting allows. You might also say what a setting values or venerates, kind of holds up as this is who an engineer is. This is sort of what we're aiming for. And if that person doesn't look like you, then you might feel you don't belong. Or if they don't do work like you, then you might feel like you don't belong. Um, so this is belonging, and that's what the topic of these studies I'm going to share is about. I'm going to look at it from different angles, and I'm going to use different methods. So I'm going to both look, in a few different settings. One's an undergraduate, mostly undergraduate, some master's students, design and manufacturing class. The other is PhD students who are, going through their doctorate. And I'm also going to use qualitative and quantitative methods, so a field experiment, a network analysis, and an interview study. So just to further kind of set up why do this? Why spend some of my, engineering doctorate focused on belonging? And to me, it's because it's really important if we're going to open up engineering to more people and to solve the big problems we face. I think having more diverse views leads to better, more innovative solutions. And there's a lot of science behind that. But even if you get more diverse, a bigger diversity of people into a space, that doesn't mean that they're going to be able to thrive in it. So that's really what belonging is about. This is a graph from the electrical engineering computer science department, which is where that quote I read was just from. It shows the gender balance over time. That quote was from 2016. I'm not sure if you can see my cursor, but in 2016, there was about 61% men in the department, so 39% women. And this is, excluding non-binary and other forms of gender identity. And so that's undergrad. You see in grad, there's even less of a balance. You might imagine, and it's true in this case, the faculty also have a challenge with gender balance. The full professors being 16% women in this particular department. And you can see that hasn't changed that much over time. There's publicly available data, so I just went and looked, what's it like here at your school. I focused on computer science because that's a lens I'm going to look at right now, because it's a good way to motivate the way I'm looking at the problem. And it's not as close to home for all of us mechanical engineers, which can be good in some cases. So computer science, at least at Mines, it appears this past year, or 2019, was 12% women in BS and 0% in the masters. If you look at the whole state of South Dakota, 12% women in computer science, which compares to 17% women across the whole country.
Yeah, so I think in mechanical, we have, 15% women in the undergraduate major population. So same paltry numbers.
Okay, yeah, cool, thanks. So you might ask, well, what do we make of that number, 15%, let's say? Is that good? Is that normal? Is that what it should be? It's hard to know, really. And there's a lot of different ways to address that question. And one way I like to look at it is to look over time. And that's why I'm using computer science here, because the over time view is really interesting. So the history of computer science education is such that there was quite a lot of degrees awarded to women early on, verging on 40% in the 80s when it peaked. And that has since continually gone down. So, you might think, well, computer science just isn't for women for some reason. They have different interests as a whole. There are certain stereotypes you might try to hold in answering this question. And I think when I look at this graph, it helps make clear to me, well, there isn't something intrinsic about women or about men. that make computer science more attractive to one group or another. You know, there's a socio-cultural thing happening here. And so I'm going to try to tease that out for a second. So this is the peak here. So back in the 50s and 60s, women were frequently employed as something called human computers. So this is doing manual calculations, sometimes using kind of simple, but very large at the time, calculating machines. So it wasn't really automated, at least at the beginning. So it's a very manual process. And women of color, you might have seen Hidden Figures or read the book. So Katherine Johnson is pictured on the right, very famous, quote, human computer who, John Glenn, turned to at a critical time when he was going and orbiting in one of his missions and said, well, can you have the woman look at it? Can she have her double check the computer's calculations? And so Katherine Johnson did and made sure it was all right. And so early on, this was a profession that was for women. It was perceived in the culture as if being for women. So much so that Cosmopolitan magazine in 1967 published an article called The Computer Girls and talked about how the starting salary was around $20,000 per year, which is equivalent to 150, roughly $1,000 in today's money. So it's a very good job. And a lot of women were doing it. So what happened is the question. Why did it change? And people have done research on this and found a big part of the story is what they call a cultural schism occurred. And that was in part because of personal computers. So, personal computers started to become available in the 70s. By the mid 80s, people starting bachelor's degrees in computer science were starting to have had significant experience at home with personal computers, doing programming. And so they were coming in with some baseline experience in programming. And this was predominantly boys. So boys were found to be 2 times more likely to be given a computer than girls. Their fathers were more prone to kind of teach them or have like a home-based internship in programming. Daughters felt that they had to fight their way to get the same attention. And that message at home was also, reinforced at school, that computers were for boys. The social atmosphere was such that computer clubs were mostly males, and those men, were also excluding women. And professors didn't help sometimes. So there's this quote from Patricia, who was at Johns Hopkins University, someone who was very good in math, but in their first computer science course recalled raising their hand to ask a question and a professor saying, you should already know this by now. And she then reflected and thought she would never succeed in this kind of major and environment, and so switched majors. And this is a sort of thing that happened a lot in computer science, and I think still happens. I've seen it here at Stanford, and it's not, I wouldn't say it's an individual, like, of course we're all responsible for our own interactions, but it's also a cultural thing. These are cultural ways of interacting. Boys at that time were seen to be more, better for, or they're just, computers were for boys, and that was part of the culture. And so because of that, women started leaving computer science, and that is a big part of what happened at the sociocultural level in this country. That is part of why we're seeing this curve go down. This other steep decline you see after the 2000s, we had a big rush into the kind of dot-com era, the boom and bust of it, and the rise of Silicon Valley and lots of firms. And there's also a very male-based culture in Silicon Valley, here where I'm based. Okay, so that's all to say there are different ways of looking at a learning environment. And these are three prevalent ways. One, the first is cognitive, and that is that learning is a process in which knowledge goes into one's mind. You organize, you develop new schema, you organize them, you become more expert in something when you have developed more of those and organized them more expertly. That is a little different than a socio-cognitive view in which you still are developing that knowledge base, but doing so depends on being part of a practicing community. This view of learning is such that learning doesn't really happen just with textbooks and with listening to a lecture per se, but being part of a group and learning by practicing in that group. And that different groups will develop different sets of knowledge in different ways of being and doing. So that's a socio-cognitive view. And the last is a sociocultural view. This is the view I'm taking here in this study and why I was talking about computer science in my introduction. In this view, it says that the social and cultural climate of a particular knowledge base of a particular profession, say engineering or mechanical engineering for us here, it has a certain social and cultural climate. And depending on that climate, certain people or certain practices will be seen as more kind of concurrent, more, they'll be more venerated in that space, and therefore will be more likely to be promoted, more likely to be given opportunities, will be more likely to call on in the classroom, will be more likely to be, sought after in group projects. All that stuff is because there's a certain social and cultural climate in that profession. And that exists in all professions, and it varies depending on the profession, and it can change over time, as we saw with computer science. So given that, I'm going to share the results of two studies. One is in a makerspace, which is a space often in universities and colleges, but also in other settings where people design and make things. The one pictured here is at Vassar. We had them at Stanford. When I was at MIT, there were lots of them. They're all over. I think you all have one where you are. And there's also a study on doctoral education. I'm going to begin with the study on PhD students. So the research questions here are, how much does a brief belonging intervention affect, and I mean causally in this case, affect retention in an engineering PhD program? The second question is not causal. How much is perceived belonging in the engineering program at entry? So baseline belonging. How much is that associated with 7 years later, people actually completing their PhD? So the design is, and this was done with a bunch of psychologists here and at other places. So it's a randomized field experiment where there was a belonging condition and a control condition. For the sake of time, I won't go into the details of the intervention itself, but the gist of it is students who were just starting a PhD across lots of different engineering programs, they participated in an hour workshop where they were given some testimonials of other PhD students who had come before them. And these are real testimonials, and saying things like, specifics around when I started in my lab, I thought, I was really worried that I was screwing up experiments. I kept making mistakes. I didn't feel like I could do it. I didn't feel like I belonged in the setting. I wasn't sure if this was for me. Stanford is this very competitive place. There's all these smart people. I'm not sure if I fit in here. And then going on to say, well, then I learned this experience is fairly common. And people who I looked up to also made mistakes, and they worked through it. And I just kind of kept learning and was able to make it through that way and succeed. And the control condition was such that they just read testimonials about study habits. Here's advice about how to study well in this particular program. So that was just an hour long. So it's a very brief intervention. And this is based on existing social psychological research where this sort of intervention had lasting effects in other settings. And so the thought was, well, maybe that can help here. It doesn't address the larger sociocultural climate issues, but it could help. So we gave it a go and then followed folks over time in using publicly available data on things like LinkedIn, assessed 7 years later, who completed their PhD and how many years did it take them. People might leave for lots of reasons, including just getting a master's and going off to industry, starting a company, becoming a CEO. So there's lots of reasons people might leave, and not just like, I wasn't sure I fit in. So all of that is happening here. This is the sample. This is split intersectionally. So URM refers to underrepresented minority students, which includes Black, Latinx, Native, and Pacific Islander. And you see here there's about 33 URM students and 166 folks who identify as white or Asian. And one of the punchlines on this study, on the first research question, is there was no significant effect of this brief intervention. Probably not surprising, given it was an hour long, and that was all over the whole 7-year period. Though there was a trend upward in that those in the belonging intervention did tend to be more likely to graduate in general, and especially among URM students. You can see these two panels on the bottom right. URM men in particular trended towards more of them graduating in the belonging condition with their PhD. Okay, well, what else can we look at there, given that the randomized experiment didn't really pan out? Well, so I looked at perceived belonging when people entered, their program. So during the intervention, before going through it, they answered these 7 questions on a survey. So this is assessing their sense of belonging at that time, at the very beginning of their program. So on a scale of 1 to 7, how much they agreed or disagreed with these different statements. I belong in engineering at this school. I feel comfortable in engineering here. Other people understand more than I do about what's going on. So that was reverse coded, etc. And these were summed up into a composite score. So I'm going to call that baseline belonging. And if you look at, who graduated with their PhD according to their level of baseline belonging, this is what you see. So on the left are students who identified as white or of Asian descent. On the right, URM is students who identified again as Black, Latinx, Native, or Pacific Islander. So if you identified as URM and you had low baseline belonging at the entry of the program, you're much, much less likely to graduate. Many fewer of them graduated with their PhD than those who at baseline had medium or high baseline belonging. This was fairly striking to see, and goes with prior literature. Whereas if you look at non-URM folks, there's really no difference. It's trending downward, but it's statistically equivalent. This is a different way of looking at that same data. So this is with a logistic regression and with fixed effects by department. So you would imagine that each department's a little different. So this using fixed effects accounts for that. And we see a significant difference between being low versus medium and high baseline belonging among URM students. So those with low baseline belonging were about 7% probability of graduating with their PhD versus medium or high being closer to 60%. And the overall average is somewhere around, 30 to 40, 35 to 40. So that's a significant jump. So this, the implication of this is how people feel, how they perceive they belong at the start of a PhD, especially among URM students, really matters for whether or not they go on to graduate. It might affect how they interact and engage in different ways and perceive the things that happen to them, the different threats that they're exposed to. Okay, so it seems like baseline belonging matters for at least this particular outcome of PhD graduation, which seems like an important outcome. So that's the first study. The second study is in a makerspace, and that is with bachelor's and master's students. So, these are photos from kind of stock photos from makerspaces where I used to work at MIT. I'm going to keep the particular makerspace here anonymous. And, I've been exposed to makerspaces at MIT, at Stanford. We didn't call them at the time makerspaces at Ohio State, but workshops. So they're very similar in many ways. People go into them. They're often they can be fairly unstructured or structured. There can be structured labs where you learn to mill, as is the case on the right-hand picture, or unstructured, where you just came in, you have an idea, you want to try to prototype, and you're not sure yet what you're going to do. So you might experiment, you might get help from people who are there. There's sometimes overseen by faculty or staff, other times they're overseen by peer students. So that really varies. But there is generally a community of practice there, people at different levels who are interacting and learning from each other. This is an example of the kinds of things that students in the class I studied make. This was a slightly different class, but just as an example, this is a product I designed and made at a makerspace here in Stanford. So the thing I designed is this orange rear rack on the folding bike. And so I wanted to make a folding rack, a rack for a folding bike that I could, ride to an airport, fold up my bike, attach it to this rack, put it in a canvas sack and put it under the airplane and have the drivetrain be protected, not get damaged, through the airline. And, this happened over 10 weeks. It went from early concepts to kind of working prototypes. It looked like, it's made like prototypes, and eventually a fairly polished final prototype. Not quite a product, but fairly far along, especially in a 10-week time frame. And so students in the class I studied did something like this. They worked on individual products and learned a lot about different machining, casting, welding, forming, and woodworking and rapid prototyping processes. So my research questions here are, in examining help as a particular key social practice, our research showed that the giving and receiving of help seems to really matter with how students come to belong in a space, in a learning environment. So given that, if we're going to look at helping, how much does help giving and receiving differ over time between students, particularly between students who hold dominant versus non-dominant identities? So I'm thinking of men versus women, white students versus underrepresented minority students, and low versus high initial levels of social connection. And by that I mean they're coming into the environment already having friends, already knowing other people in the makerspace, already having a relationship with faculty or staff in that makerspace, versus those who do not. Other dominant and non-dominant identities include socioeconomic status, and so that's going to become important here. So whether you grew up with high, medium, low income family, or you're a first generation college student, etc. The second question is, how do students access help? And how does this relate to belonging in the space? And finally, what are other sociocultural aspects of a campus makerspace involved in how students come to belong there? So the data we collected was both qualitative and quantitative. We did we did 5, what's shown here is 4 surveys over time. They're spread out about every 2 weeks. And we also did 4 rounds of interviews. These interviews were with the same 6 students over time. So this is a longitudinal study in both surveys and interviews. The surveys were analyzed using a network analysis. So you see that on the bottom row. So there were 33 students out of a class of about 80 who answered every survey. And so we could actually follow them without any missing data over time. So this is not a representative sample. And this particular class may not be representative of all of engineering, but this is just a particular group to see, and it's a fairly diverse group. Are there differences among the different students in how much they give and receive help? So they were asked these 2 different questions. Please select any course instructor, course assistant, or student, peer, whom you have received information or support over the past 2 weeks. And they were asked that every 2 weeks. And then also, for each of those people selected, please indicate how often you received information or support from that person, again, over the past 2 weeks. So using that information, you can see, who students perceive they're getting help from. And then based on that data, you can also see who is being perceived as giving help to others. So we can look at it both ways, but it's always from the perspective of the help receiver. I used a deductive analysis here, and you'll see that more details over time. In the top row, I, with a team, collected interview data. We asked questions that really aimed for critical incidents, which just means like things that stand out, experiences in the makerspace that stood out to the students. Times when things went well, when things didn't work, things broke or things failed in some way, and how they interpreted that, how they got help or how they didn't, why, and just stories like that. And we inductively analyzed those, which involved open coding without a sense yet of what we were going to find, and then focus coding to build some theory. So this is of the vein of grounded theory for those of you familiar with qualitative work. So I'll look at the first research question first, which is, how did the amount of help giving and receiving change over time? So this is the network data. This is an example of a network graph that was made. I believe this was at week 3. The names of students shown are the interviewed students. These are all pseudonyms. So those will play later in my results. And blue, or this sort of maroon or salmon color, is students. Yellow is interviewed students. The teal or green is the course assistants, and the purple is faculty. And you can see the arrow of the direction that the help is moving. So you can see here, some students, some CAs are more central in this network. They're giving and receiving more. And those on the outside are more peripheral. And my analysis, I'm actually able to quantify that. It's called a centrality score, how central or how peripheral you are. So the more central you are, the higher that centrality score is. So I'm using that as a measure of how much help is being given or received, depending on the direction of the arrow. So these are the results. It looks, I'm going to show it according to different subgroups of students. So this first one is 3 groups. Those with a lot of prior making experience. This is self-reported. So those who came in, they already had machined something before, they had already welded, whatever it was, they had some prior experience in that making process, or those with some, or those who felt they had no prior experience. And you can see it did vary in that, you would expect those in the lighter gray who had lots of prior experience would receive less help. It did trend that way. You can see, well, I guess I don't know if I can point to it, but you can see in the middle, the lighter gray there, it's trending down lower than the other two. But overall, these are not statistically different. So overall, at least in terms of prior making experience, these are all about the same in terms of help received versus help given. And this, I should have mentioned, is over time. So this is at weeks 3, 5, and 7. So overall, people are receiving more help between week 3 and week 5. But statistically, it doesn't vary depending on the amount of prior experience you have. And help being given isn't really changing in this view over time. We can look at it by gender, so men versus women. And again, we see a similar trend, but no major differences between the two groups. We can look at it by race. So in the dark triangle is students who identify as Black or Latinx, and the lighter circle is students who identified as white or Asian descent. And in terms of help received, again, no difference. In help given, there is a slight difference in that during week 5, which was a particularly critical time in the course, those who identified as Black or Latinx were perceived as giving others more help than those who identified as white or Asian. We can look at it by first generation college and low income versus those who are not first generation and who came from higher income backgrounds. In this view, we do see that at least by the end, students who come from lower income, I'm calling them non-fly backgrounds, were receiving less help. So those who are coming from more advantaged, socially or economically advantaged backgrounds were getting more help by the end and trending over time than those who come from lower income backgrounds. So that might be somewhat alarming. And then lastly, we could look at this according to the number of prior relationships students had when they entered the makerspace. So each student was asked to list, who are the people that you already have some relationship with, as they first entered the class. And we counted those up, and those who had 7 to 13 prior relationships were in many category. 3 to 6 was some, and 0 to 2 was few. And we can see here that at the beginning and over time, those who started with many prior relationships, which you might expect at the beginning, people who know more people are probably going to give and receive more help just because they're part of the social fabric. But you would hope it would level off over time, right? As you're engaging a lot and interacting a lot. But in this case, we're seeing with this particular sample, and it's a small sample to be fair, we're seeing it diverge. So those who started with a lot of prior relationships actually are gaining even more help over time than those who started with few prior relationships. So this is to say, well, actually, maybe it matters a lot at the beginning. As educators, we need to pay attention to who has friends in the class, who has some kind of relationship and who doesn't. And can, at the very beginning, we create opportunities for those relationships to form so that we can level out this difference, this disparity. That's if we believe that getting help matters in an engineering class, which I think you could argue it matters a lot. So the last 2 questions are, how do students access help? And how does this relate to belonging? And what are other sociocultural aspects involved in coming to belong? So this is the interview data. These are the 6 students who were interviewed over time. You can see that they varied. Cindy and Darren had low prior relationships, low prior mating experience. They also varied in terms of race and gender and first generation low income status, but they were all of mechanical engineering flavor, product design, architecture, biomechanical or mechanical engineering, all later stage bachelor's or first year master's students. Brittany and Victor are kind of in the middle in terms of prior relationships, still low making experience going in, and Jennifer and Max have high prior relationships and making experience. So I'm going to focus more on Cindy, Darren, and Victor in what I share here, and Brittany as well. I'm going to go a little bit faster for time here. So this is how the qualitative results played out. We found that students described feeling they belong in the makerspace when they felt that they could express their whole self, when they felt they had authentic relationships, and felt that they could engage via their own frames. And I'll explain what I mean by that. So this whole self-expression, Victor shares a nice illustration of this. So one of our homework assignments is to write an autobiography about yourself. And it gave me a chance to reflect. And I just thought of a lot of key attributes that define who I am. I'm a runner, I love cooking, and I'm Nigerian. And I was like, oh, wow, if I can blend 2 out of the 3, I can make something I'll be proud of. And that's why I'm trying to dedicate my class project to my love of cooking, as well as my Nigerian culture. The fact that I can draw so much of me in really helps inspire me, especially in those moments where it can be very difficult, like, oh, this is a lot, this may seem overwhelming. But the idea of, okay, I'm working towards something that I want to be proud of, and that's just what it takes. I couldn't share his example to, for his privacy, and again, that's a pseudonym. But here is a student whose project is publicly available and is a particularly inspiring project. And this is how he describes it. So he made what's pictured here on the right, this folded sheet metal and riveted fruit picking product. I made this fruit picker for my father on our farm in Florida. Since we were children, my brother and I had the weekly task of picking the mandarins, oranges, and lemons from the trees. One of us would climb a ladder, pick a fruit, and drop it on the ground. The other would pick it up and place it in a basket. Since my brother and I left for college, we haven't been around to help. This fruit picker was made with a specific aesthetic. 2 pairs of hands, you can see there, to represent my brother and me. That way our dad will always have our support and help, even from miles away. So you can see there's deep meaning within this product for the student. This is a way to express more of his self in what he was doing, what he was learning in the makerspace. So that is what I mean by expressing their whole self, creating assignments, creating opportunities for that to happen and to be valued. This particular project is shown as an example to other students of what is a really good project. And that's important too, for changing the socio-cultural environment that I talked about earlier. Or just reinforcing what we want to keep, within that environment. The second one I'll skip. It's fairly obvious, the role of prior relationships really matter. You'll see, if you want to come back to this in the video and read it, Cindy does not come into the class with prior relationships and Darren does. Even though both of them didn't start with many prior relationships. And for Cindy, that really affected her experience in class. And I'm going to then focus on this idea of frames. So in our analysis, this sort of theory building analysis, we found patterns in the way students asked for help. And we're calling them these frames of asking. So there's knowledge seeking, affirmation seeking, and collaboration seeking. Knowledge seeking is asking questions like, how do I do this? What went wrong? How might I fix it? Affirmation seeking is, I tried it. Does this look right? Can you watch and tell me if something looks wrong? So, looking for affirmation, but already having some knowledge. Versus collaboration seeking. Can we brainstorm possibilities together? Can we help each other out on this more in a peer-like manner. And so you could think of these as a linear progression that students go through as they gain more experience. We did see that in our data, though we also saw highly experienced students sometimes, engaging with a knowledge-seeking frame or an affirmation-seeking frame or a collaboration-seeking frame. It just really varied depending on the situation. So I'm going to try to tie together, why these frames matter and how they affect belonging in a space. So I'm going to do that through one example, and that's of Brittany. And this will be my last piece of data here, and I'll close. So Brittany says, I came in one night to finish and wood glue my pattern. And the CA on duty, I'd never met before, he looked at it and he was like, why aren't you laser cutting this? I was like, because I was told to hand carve it. Later that evening, I asked him for help because I didn't have any wood glue. And he was like, you've wasted your entire time. This should have been laser cut. It could have been done in an hour. I was already super stressed because I had spent so much time on it. So it had made me feel really frustrated with the CAs who had told me not to laser cut, and also with him for being so negative. So he helped me wood glue it, but he didn't really help me. And so we put the wood glue together and it didn't go straight. And I was like, can I adjust it? And he's like, no, it's too late now, it's done. And we just walked away. It was hard because I'd gotten a bunch of opinions before he came in and said that everything was wrong and it should have been laser cut. So that was super frustrating. I had to just not be in the makerspace for a couple of days after that. I talked to my coach and he was like, I'm so sorry that this happened. There are reasons why I told you to hand carve it and not laser cut it. And those reasons made sense to me, she says. Then it was a lot better. My coach helped me finish wood gluing and it worked. So she actually rammed up her pattern in a sandcasting mold, poured it, and it worked. So all is well now. While I didn't really want to be in the makerspace or be in that community for a specific time, it wasn't necessarily that I felt unwelcome, but I think that I did feel like I was a student and he was our instructor and telling me the right way to do it, like what I had been doing and what I thought was wrong. And so I guess that didn't necessarily make me feel excluded, but it definitely made me feel like lesser than. So a kind of way to step back and try to make sense of that is that students come into a situation with a frame. If they're asking for help, they're engaging a particular frame as they're asking for that help. And if the person providing the help or being asked to provide the help doesn't pay attention to that and provides, their response with a different frame, it's a mismatch, especially if it's an imposed lower order frame, then it can lead to students, not feeling like they belong in this case. So she says, it didn't necessarily make me feel excluded, but it did make me feel lesser than, so not as valued in the space, and therefore maybe not belonging as much. It also can affect one's self-efficacy or their confidence in the space. You could also imagine the reverse, if a student comes in with a knowledge frame and the person they're asking for help responds with an affirmation frame or a collaboration frame, that could boost their belonging or their self-efficacy, their confidence in the space. So in conclusion, these several studies are about belonging, show that belonging is more than leaders, in that learning environment stating, you're welcome here, but actually cultivating a social and cultural environment where all students can express their whole selves, can have authentic relationships, can access help, by accessing social learning resources, other people, and doing that as easily as other people can. We saw in my data that there are disparities in who is accessing help, and that seems to be patterned by who has prior relationships and whether you are socially or economically advantaged due to your background, your SES background. Also, we're in an environment where students can be met with concordant help asking frames. So if I put out a collaboration frame, I'm met with one as well. And where students feel valued and, quote, not lesser than. Finally, what are the implications for people like us, people who are teaching engineering? Well, I think some of them are, and I'm still making sense of this too. How does this affect my teaching in a technical class? Well, I think one of the things is it means I need to attend to the social relations and not, in addition to the technical content. So assuming that students come in with different levels of prior relationships, what can I do? What activities can I present? What situations can I present to students so that they can more easily form relationships with each other, with me, with other teaching assistants at the beginning of a class or of a PhD program? Um, how can we attend to students' help asking frames? So paying more attention to not just the content of a question, but the underlying frame and matching it, or helping push it forward so that students can feel even more like they belong. And lastly, providing dedicated resources to students who are disadvantaged in some way. So that could be low SES students. In this case, we saw that mattered for who had access to help. But in other settings, it could be something else. And it really just depends, in the computer science example, we saw that men who had personal computers ended up having an advantage over other students when they entered the computer science program. So paying attention to situations like that and trying to, at the beginning of courses or programs, or even before them, creating initiatives to level that field. All right, I'll stop there for questions.
Great, thanks, Eric. There's a lot of things that are bouncing around in my head, and I'm surprised. I mean, maybe it's implicit for you of making the connection between what the experience is as a PhD student and what the experience is in a makerspace. Both is ambiguous, and there's a lot of self-regulated learning and self-direction, and maybe an expectation that other people have figured it out, right? And so that kind of ambiguity or uncertainty that seems apparent, right? And it's like, oh, I feel like as an individual that might just be me rather than this holistic experience for everybody.
Right.
I mean, it also, like, for me, like right at the core of like some intellectual curiosity of what happens with design coaching and pedagogical content knowledge, right? So like you might know the answer to it, but you're trying to get a student to get there on their own, right? Or like that they, I have an 8-year-old, like there's a lot of things that I see him doing that like I realize that he has a misconception of the world, right? But he's being internally consistent and true to himself. I'm curious about taking any of these insights and making things that would change that sense of perceived belonging or fit, right? Like I'm thinking of like you mentioned Jane Margolis's Unlocking the Clubhouse. I think that's Carnegie Mellon, right?
That's right.
And like Rebecca Nathan, like there was another book that came out of some ethnography of like she was a tenured professor and then as a sabbatical like lived in the dorms as a freshman, and there are all sorts of like sociocultural things that she called out that you're like, oh yeah, that's remarkable, that of course that's why there's only 15% women, right? There's other majors beyond mechanical engineering where there's a stronger like intrinsic motivation and that is activated. I'm curious what you're in the makerspace, maybe particularly, or in the context of mechanical engineering courses, if there's some things that you lean on as shortcuts to get at some of these frames. Like I mean, maybe I'm jumping ahead because I'm thinking, oh, I've had this experience in this class. I like you gave the example of the agricultural picking device, and it's like, oh, I remember I made something silly in the class. Somebody else made a tortilla press, and it was like, oh, totally much more of a meaningful contextual thing, right? the manufacturing processes were maybe very similar, but like my friend who did this was far more engaged in their project than I was.
Right. Yeah, I don't know if there are like quick kind of fixes and shortcuts, you know, to this sort of challenge. But
Well, yeah, I mean, maybe your big idea is that the sociocultural aspects of things, right? Like I think Harvey Mudd College has done something with their computer science undergraduate program to achieve gender parity, and a lot of it is the on the sociocultural side of things.
yeah, yeah, I'd be interested in learning more about that. You know, in the makerspace here at Stanford that I've been heavily involved in, there is gender parity, and both like in the student body who attends, which are mostly engineering students, but also in the teaching assistants who run the place, and that seems fairly unusual, and it does seem to matter a lot, you know, in whether or not I feel I belong as a woman versus as a man. But also, I think a big part of it is, you know, as instructors, we can pay attention to who we're holding up as exemplars, right? Like,
Mhm.
there are lots of ways to do an engineering design project. And there are, you know, as you were saying, Micah, like there are many um, ways for a project to be meaningful. And if we're just holding up, you know, particular ones that particular students make, then it does make the other folks feel like, okay, maybe what I'm contributing isn't as valuable. And I think that happens not because as engineering instructors we're doing it on purpose. I think it more happens because we hold up the things that we see as more like
Mhm.
what we would do, you know? And if most of us are white men, then we will do that more for white male students. But
Great.
it's just a matter of paying attention to that. And I do see places, you know, like I imagine it's true at Harvey Mudd. It was true in mechanical engineering at MIT, which also has gender parity. I see it happening here at Stanford. So
Mhm.
paying attention to that as an instructor can go a long way, I think.
Right. I don't think we're there yet here within maybe our department. I mean, it's a STEM focused institution across the board. If you include, you know, some of our colleagues who are in the humanities and the social sciences, I think our faculty is around 40% women. Um, but yeah, I mean, it is an interesting thing of like talking about framing. So my mom, and I didn't realize that there was a phrase for this, but she was a computer girl, right? She worked for IBM, right? Like there's a little bit of like she worked. She's now retired, but she was a computer scientist working for the Navy in Monterey, and her office was on Grace Hopper Lane, right? It's just like, oh, not everybody's mother is an engineer. I you know, like what else do I know, right?
Right.
All right, cool. So let me put a pause on the seminar. So I'll stop recording, and this is maybe an interesting conversation to consider and continue with. It's certainly relevant to some of the things that we're uh, concerned with and mindful here in our department. All right. Well, thank you, Eric. Let me stop the recording then.